the number of meaningful digits in a given number is called as the number of significant figures. If the number is less than 1, the zeros right to the decimal point left to the first non-digit number are considered as insignificant. All the non-zero digits, which means the number which is apart from 0, they are significant. Hello everyone, welcome to session 4 of chapter 2, Units and Measurements. This is Swati, Faculty of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in today's session, we are going to study about the significant figures and also the rounding of the digits and also many more interesting concepts. So let us start with the first topic, that is significant figures. So what is the meaning of significant figures? So while talking about the numbers, the meaningful digits that are present in a given number are called as significant figures. Yes, the number of meaningful digits in a given number is called as the number of significant figures. If I tell you the number, some number like 1, 2, 3, 4, 5, 6, 7, and if I ask you how many number of significant figures you have in this given number, we must be able to say one particular number that tells that the numbers of significant figures we have. Yes, let us understand this by studying few examples. Now, significant figure is nothing but the meaningful digits that are present in a given number. Now, what are the rules to find the number of significant figures? The first rule is all the non-zero digits are called significant. All the non-zero digits, which means the number which is apart from 0, they are significant. You can observe this example. I have 3, 3, 1, 2, 3. Here I don't have any 0. So all these are non-zero digits and all these are significant. So in this example I have 1, 2, 3, 4, 5. There are 5 significant figures in this example because I have all the digits are non-zero. So the first rule says that all the non-zero digits are significant. And the next one, all the zeros between two non-zero digits are significant. So it says that the zeros which are present between two non-zero digits are significant. Observe the example. I have 8, 0, 0, 2. Here the zeros which are present between two non-zero numbers. In this case, the zeros are also considered as significant figures. So in this example, I have total 4 significant figures because these two zeros are also considered as significant since they are present between two non-zero numbers. So I can write one more example for this. Let us say 7, 0, 6, 0, 2. So here also 0 is present between two non-zero numbers and here 0 is present between two non-zero numbers and hence they are also considered as significant. So total I have 5 significant figures in this example. So the second rule says all the zeros which are present between two non-zero numbers are significant. And the next one, if the number is less than 1, look at this example 0.00150 and this full number, it is less than 1. If the number is less than 1, the zeros on the right side of the decimal point. You can see I have a decimal here and the zeros to the right side of the decimal point but to the left side of first non-zero number. Here 1 is a non-zero number. So left of the first non-zero number, right to the decimal point, these zeros are considered as non-significant numbers. I hope it is clear. If the number is less than 1, the zeros right to the decimal point left to the first non-digit number are considered as insignificant. So this is the third rule. So next we have the zeros at the end of the number without decimal point are not significant. You can see this example here. I have no decimal point. So when there is no decimal point, the zeros at the end of the number are considered as insignificant. They are not significant. So next, the zeros at the end of a number with the decimal point are significant. See, look at this example. I have 7.300. I have a decimal point here. So the zeros which are present at the end of the number, when there is a decimal point, then it is considered as significant. If there is no decimal point, then it is considered as non-significant or insignificant. So when there is a decimal point, then the zeros are considered as significant figures, and when there is no decimal point, if the zeros are present at the end, then they are considered as not significant. So let us see few more examples. The first number I have 33123 or 33123. All these are non-zero digits. So all the non-zero numbers are significant, and I have all the non-zero numbers here. So the total number of significant figures present in this example is 5. Similarly, I have one more example 1, 2, 3, 4, 5, 6, 7, and all these are again non-zero numbers. Since there is no zero here, all the digits are non-zero, I have 1, 2, 3, 4, 5, 6, 7 significant figures in this example. Next I have 7, 8, 9, 1, 0. Here 0 is at the end of the number and there is no decimal point. So the 0 at the end of a number without decimal point are not significant. So according to this, we should not consider this 0, and I have only 1, 2, 3, 4 significant figures in this example. Next I have 1, 2, 0, 0, 0. Here also all 3 zeros are present at the end of the number, and hence they are not significant because there is no decimal point. So we have only 2 significant figures in this number. So here we have 0.0050830. Here there is a decimal point. Since there is a decimal point, this 0 is considered as significant, and this 0 is present between these two numbers, and this is also a significant figure. And next I have 0.00003400. Here the zeros after a non-zero number, and there is a decimal point in this example, and these two zeros are significant. And here the zeros, 4 zeros, right to the decimal point, left to the first non-zero digit, these are considered as insignificant. They are not significant according to rule 2. Now let us see few more examples. In the number 207.5, here 207.5. 207.5, the digits 2, 0, 7 and 5 all are significant figures because 5 is a non-zero number, 7 is a non-zero number and 2 is a non-zero number. All 3 are significant figures, and this 0 is present between 2 non-zero numbers, and hence it is also considered as a significant figure. So there are total 4 significant figures in this example. Next, in the number 0.0032, the significant figures which are present in this example are, let us see that 0.0032. 3 is a non-zero digit, 2 is a non-zero digit, but after decimal, the 0 right to the decimal point and left to the first non-digit number, they are considered as not significant figures. So we have only 3 and 2 are the numbers which are significant, and hence we have 2 significant figures in this example. Next we have 14800. The number 14800. Here we have zeros at the end without decimal. So when there is no decimal, the zeros at the end of a number are considered as not significant numbers. And hence we have only 148 are the digits which are significant, and we have 3 significant figures in this example. And next, in the number 0.8370, all the digits, that is 8, 3, 7 and 0 after the decimal point are significant, because if there is no decimal point 08370, then this 0 is also considered as insignificant, but we have 0.8370. Since there is a decimal point, if the 0 at the end of a number is present, then it is also considered as significant. So in this example 0.8370, all the numbers, that is 8, 3, 7 and 0 after the decimal point are considered as significant, but the 0 before the decimal point here is insignificant. It is not a significant figure. Now, these are some basic rules to find the number of significant figures. Now, let us see what are the rules for arithmetic operations with significant figures. Arithmetic operations such as addition, subtraction, multiplication and division, what are the rules that we need to consider to mention the number of significant figures? So, in multiplication or division, the final answer should retain the same number of significant figures as there in the original number with least number of significant figures. I'll tell you the example. See, we have an example 8.436 into 10 power minus 3 kg of mass of a body. Suppose if we consider there are 4 significant figures in this example, that is 8, 4, 3 and 6, and its volume is measured as 2.54. We have only 3 significant figures in this. In the first term we have 4 significant figures, in the second term we have only 3 significant figures. Now the density of a body can be calculated by the formula mass by volume. Now mass is 8.436 and volume is 2.54. When you divide these quantities, you will get the answer 3.3212 and so on. But here I retained only 2 digits after the decimal point because the rule says the final result should retain the same number of significant figures as there in the original number with least number of significant figures. So these two are original numbers. These two, we have 4 significant figures in the numerator, in the mass of the body given, and we have 3 significant figures in the volume. And here you can see after decimal point we have only 2 digits, which means totally I have 3 significant figures, and in the result also I have only 3 significant figures, because as per the rule says the final result should retain the same number of significant figures as there in the original number with least number of significant figures. Here the original number with least number of significant figure is 3, and hence the final answer is also retained with number of significant figures, that is 3, and hence I have taken only 3.32 into 10 power 3 instead of 3.3212 and so on. This is one of the rule for arithmetic operation with significant figures. That is about multiplication and division. What about in addition and subtraction? In addition or subtraction, the final result should retain as many decimal places as there in the number with least number of decimal places. Yes, if two bodies have masses, for example 3.432 and 2.16. Look at this example. I have 4 significant figures in this and 3 significant figures in this. So the sum or difference of their masses must have 2 decimal places, because when you have 3 significant figures in this example, that is 2.16, I have only 2 decimal places. According to the rule, the final result should retain as many decimal places as there in the number with the least number of decimal places. So here the least number of decimal places is just 2, so I have to retain the same in the final answer. So let us add this. 3.432 plus 2.16 give us 5.592. So instead of 5.592, we are considering just 5.59 according to the rule. Here, while subtracting 3.432 minus 2.16, we have retained only 1.27 because the final result should retain as many decimal places as there with the least number of decimal places in the given number. So these are the rules to be followed for arithmetic operations with significant figures. We use calculators in our daily life widely. So in calculators, sometimes we will get so many number of digits. So our next concept is rounding off the uncertain digits. So to avoid such long numbers, we can round off the number to certain value. What are the rules to be followed to round off a number? Let us see that. So the results of calculation with a number containing more than one uncertain digit should be rounded off. The rule by the convention is that the first rule is the preceding digit is raised by 1 if the significant digit to be dropped is more than 5, and it is left unchanged if the latter is less than 5. For example, if I have 1.347, this is a number. So now the 7 is more than 5 or it is greater than 5. So in this case, As per the rule, the preceding digit is raised by 1. Here in this example, the preceding digit is 4. So this has to be raised by 1 because the number 7 is more than 5. So the answer will become 1.35. Since it is raised by 1, I have written 1.35. And this is left unchanged if the latter is less than 5. Which means what? It can be left unchanged. That is 1.344. Suppose if I have a number, this number is less than 5. In this case, the preceding number is left unchanged, which means it will be rounded off to 1.34. I hope this rule is clear to everyone. So let us see the next one. If the insignificant digit to be dropped is 5, it is neither more than 5 nor less than 5. If the number is 5 itself, then what we should do? Then the insignificant digit is simply dropped if the preceding number is even. What if the preceding number is odd? So if it is odd, it is raised by 1. The preceding digit will be raised by one number when it is odd. Or if it is even, it will be simply dropped. Let us see few examples to understand these rules. So here are a few examples to understand the concept rounding off. So first one we have 1.344. You can observe here the number 4 which is less than 5. So if it is less than 5, then the number is left unchanged. The preceding number will left unchanged and the result I get is 1.34 after rounding off. Next I have 1.346. So here the insignificant number is 6. In this case, 6 is greater than 5. So when it is greater than 5, the preceding number should be raised by 1. So in rounding off this number, when the preceding number is raised by 1, we get 1.35. Next I have 1.352. You see here 5 is followed by 2, that is the number which is other than 0. Then the preceding number of 5 should be raised by 1. After the rounding off, the number will become 1.4. And next we have 1.3450. Here 5 is followed by number 0. In this case, you must observe whether the preceding number is even or odd. Here I have 4. 4 is an even number, so it is left unchanged and the rounding off will be 1.34. Because it is even, so the number which is insignificant here is 5 itself. It's not more than 5 or less than 5. So in this case, we must see the preceding number. If it is even, it will be left unchanged. If it is odd, it should be raised by 1. So let us see the next example to understand this better. 1.3150 I have. So here 5 is a number, which means you have to see the preceding number. Preceding number is 1 here. Number 1 is a odd number. So in this case, the preceding number will be raised by 1 and the number will be rounded off to 1.32 according to the rules of rounding off the number. We have few more examples here. So a number 4.787 is round off to 3 significant figures. That is, after rounding off, I have 4.787. Here 7 is greater than 5. So when the number is greater than 5, the preceding number should be raised by 1. So here when we round off this to 3 significant figures, the answer will 4.79 because this number is raised by 1 since it is a preceding number of the 7. 7 is greater than 5. Next, a number 6.345 rounded off to 3 significant digits, that is 6.34. How it is? So it is 6.345. Here the number we have 5. So the preceding number of the 5 is 4. 4 is a even number. So when the preceding number is even, so the result will be remained unchanged in preceding number, and to 3 significant figures, if we round this off, we get 6.34. We have one more example, 4.375. So the number 4.375. So 7 is an odd number and 5 is the insignificant figure. Preceding to that, we have an odd number. In this case, we need to raise this preceding number by 1 and hence it will be rounded off to 4.38. So these are certain rules to find the number of significant figures and to round off the uncertain digits. So in today's session, we have learnt what is a significant figure, how to calculate the number of significant figures, how to round off the uncertain digits, and many more things. In our next upcoming sessions, we will come up with some more interesting concepts. Until then, all of you please take care. Thank you.